All right, good afternoon, mathematicians. We are trying our flipped classroom where you will be watching this video and copying your own notes for finding the surface area of rectangular prism. So let's go ahead and get started. Here we have a few fill in the blanks that you're going to do. Notice that we have a rectangular prism and our directions say to copy the dimensions of the rectangular prism to the net below. So just like we've been practicing in class of transforming 3D figures into nets, that's what you're doing here in this example. So what it has you do is to take a look at the dimension. So again, this is exactly what we did in class today, as in Tuesday and also Monday. Here we have the long side of the rectangular prism as 11 centimeters. So I would transfer this 11 centimeters to the length of this rectangle, which if this length is 11 centimeters, then all of these would also be 11 centimeters. At this point, notice that I color coordinated the 3 centimeters and the 4 centimeters. So remember, when you take a 3D image and basically unfold it, you have to figure out where each dimension goes. So if we're talking about rectangle A, here we have, again, the length is 11 centimeters. If we were to take this side and press it out flat, the height of the triangle is actually 3 centimeters. So that's why the 3 centimeters is here. So let's see. Rectangle A is actually this rectangle right here. So I did the same thing for each of the following rectangles. Again, writing the dimension and then labeling it here with the net. Now down here you see lots of different numbers. What these numbers represent, if you read this question right here, it says use the information to determine the area of each rectangle. So that's where I'm going to take the area of rectangle A, B, C, D, E, and F. To find the area of a rectangle, remember we multiply base times height. So once I find the area of each of these rectangles, it asks me to find the sum. Remember, the sum means to add. So you're going to add all 6 of these faces. Once you do that, you get 178 centimeters. Make sure that you actually go through with each rectangle calculating each of the areas for those faces. Down here we did the exact same type of problem. Let's see if I can adjust. There we go. So this question says to decompose each net into different congruent figures. Remember, congruent means equal or equivalent. Then find the area of each figure. Notice again that I color coordinated these rectangles. The reason I did that so you can see which two match up, which two are the same. So we have the 2 orange ones, the 2 blue ones, the 2 green ones that are all the same. So shape 1 I called the green rectangle. To find the area of this shape, this is a rectangle, so I would find length times width. I would take 8 meters times 6 meters, and I get 48 square meters. Once I do that with each of the rectangles, all 3 shapes, I have their 3 areas. Now to find the surface area, we would add all of the areas together. So notice that here I have shape 1, shape 2, shape 3. I have those 3 areas, but I actually have 6 faces. Okay, remember that each rectangle actually has an opposite side. So what we end up doing when we find the total surface area, if we have shape 1, which was 48 square meters, we actually have 2 rectangles that are 48 square meters. So each time you're taking the area of each shape, you actually have to do it twice because there's 2 of those faces. When you add them all together, that equals the total surface area. So make sure that you read over each of these questions, that the total surface area is the total area of all 6 faces. So again, basically to find the surface area, and we can add this as a Q. Surface area equals the sum, which means to add, of all faces. Faces are the outsides. So it's the area, the sum of all, I should say that differently. The sum of the area of all faces. So if you take all of the areas and add them all together, that equals your surface area. Okay, so you take the area of all of those faces, add them together, that equals your surface area. On the second page, there we go. We talk about lateral surface area. Lateral surface area is the covering of the surface of a solid except the bases. So once you identify the bases, the lateral surface area is the area of the other faces. So here we have determined the surface area of the objects below. Okay. Now you may be asking, well, how did I know to identify this as the base and this as the base? Well, we see that we have the dimension of this length and this height. We also have the dimension of this length. And if this height is 5 centimeters, then this is 5 centimeters, this is 5 centimeters, this is 5 centimeters, and this is 5 centimeters. So really we have the dimensions of rectangle number 2 in green as well. So if we have the dimensions for the red rectangle and the green rectangle, the two that we don't have the dimensions for, we're calling those our bases. So lateral surface area, again, is the surface area of a solid without the bases, so basically minus the bases. So if I found the area of the first rectangle, again, this is a rectangle, so I multiply base times height, 4.2 times 5, we get 21. Now, why did I multiply by 2 right here? I did that because I not only have one face that have those dimensions, but its opposite face also has those dimensions. Think about the box that I showed in class. The top is the same as the bottom. The back is the same as the front. One side is the same as the other side. So once we find the area of one of the faces, we can multiply it by 2 because there are 2 faces with those dimensions. Again, to find the lateral surface area, it's the area without the bases. So basically, I would add the area of rectangle 1, which is 21, but times 2, there's 2 faces, plus the area of rectangle 2, which is 14.5. There's 2 of them, which equals 29. I add 42 plus 29. That gives me 71 square centimeters. Remember, we're talking about area, so our unit needs to be squared. The other 2 questions you're going to complete, we have number 3 and number 4. You're finding the total surface area of each of those shapes. Pay attention to the vocabulary. For example, this says cube. That tells you that that shape is made up of one 2-dimensional shape. That would be a square. So if it gives you 1 dimension, you actually know all of the dimensions. Good luck. We will talk about this in class further. I hope this makes sense. Be persistent. Have endurance. We will practice again in class and answer all of your questions. Good luck.